take a topic. Anyway, we have to learn this topic, set and dictionary. Okay. So I will teach set and dictionary. But just remember that all the things, what we have learned till now in collection, that is list, tuple we have learned. Some things about tuple is still pending, like pack. There is a word called pack a tuple, unpack a tuple. Trust me, I will come back to this topic, okay? Tuple. But we know list, we even know list comprehension. We have learned tuple and its properties. Today we will learn set and dictionary and their properties. But our plan, ultimate plan should be to take all of them together. Finally, to see all of them together and how they constitute, how they help in real world programming. Okay. So, but first we are learning this in bits and pieces. We are learning them separately. But we have to learn what is the relation between set and list. Can dictionary and list go together? In which type of programs we will use dictionary? In which type of programs we will use list? Like that. Okay, so all the things have to be planned together, but not now. So let's see what is set. Set in Python. And set after all contains some elements, like we can have set like this also, you see. Y is equal to set, let's say ABC, DEFGH, I, PQR. So this is a set containing 3 strings, or we can have set containing some float values like this, 80.9. So basically, just like list or tuple, set is also a collection. But what makes set different from other collections is its properties. Remember, my dear students, there are 4 types of collections in Python. Start: list, then tuple, then set, then dictionary. List, tuple, set, dictionary. Whenever you are asked definition of any of them, then you should give definition only in 4 statements. Like suppose if you are asked, what is a list in Python? Don't give long bookish definition. List in Python, it is a collection, first point. Second point, it is ordered collection. Why? Because list has that index 0, 1, 2, so ordered collection. Next point, duplicates are allowed in the list. You can store duplicate values in a list. Next, and very important point is, it is mutable collection. Remember, you can change values inside a list. And last point is, it is iterable. So basically, if you now try to write properties of set, you should write it in four lines. That's all. First property. It is unordered collection. Unordered collection. What does it mean? That if you are having this set, you see 10.5, 20.5, 80.9, suppose, then you should not say that 10.5 is at 0 location, 20.5 is at first location. There is no location numbering. There is no indexing in set. That means set is like, random collection. It's not that this value will be after this value or that value will be after that value. There is no ordering. You can call it as random collection, but better word is unordered collection. Whenever you hear this word next time, maybe in any other language, unordered, then that means you should understand, okay, there is no indexing. Location numbers are not there. Second property is duplicates are not allowed. Duplicates not allowed. See, in set theory, we have learned in high school that in set theory, set is collection of unique values. Like when we say set of students, then in that set, if there are 10 students, then we don't have repeated occurrence of the same student. It's very funny, isn't it? So basically, let's say I write a statement like this: x is equal to, these are the values in the set. I am storing 1, then 2, then 3, then 1, then 2. See what I have done, I have repeated 1 and 2. 1 and 2 is repeated. So if I write such a statement, then there will be no error. Python will not report any error. But when I print x, when I print this entire set, then the output printed will be 1, 2, 3. That means as a programmer, even if you try to repeat the values forcibly, if you try to store 1 or any other value again, then Python will simply suppress those values. It will not store them. But this is not true about list. If you write square bracket, list square bracket, inside that you can repeat the values. So first property is it is unordered collection. Second is duplicates are not allowed. Third point is it is mutable. That means you can change. Change a set. You can. This is a big point. I am coming to this. And fourth point is it is iterable. My dear students, you will be able to answer any collection properly. 4 collections are there. If you remember 4 points about those collections. Okay. Let's take a demonstration very quickly on set. Here we are in Python idle shell. I'll just maximize this. And I'm writing simple commands. I am not writing any programs as of now. So suppose I write x is equal to curly brace 1, 2, 3, 1, 2. This is a set because curly brace is given. And I have repeated some values. But then if I print x, just observe it will print only 1, 2, 3. That means this 1, 2 was suppressed. Okay. I can take any type. It's not necessary that it should be only integer values inside a set. I can have like 1.5, comma, 2.8, comma, 9.6, comma, minus 1.3, comma, 7.4. 5 values I have taken. Oh, I did some. Oh, I wrote a dot here instead of comma. Happens. Can I copy paste this? I don't want to type it again. Okay, I'll copy paste and I'll change this. This by mistake I wrote a dot there. Okay. Now let me try to print this set y. Something strange you should see in the output. Okay. Just see, notice the output. This was the set I gave. Just check. This was the set 1.5, 2.8, 9.6, minus 1.3, 7.4. Look at the sequence in which I gave the values. But when I am printing y, all values are printed, definitely. But after 1.5, 2.8, 7.4 was printed. But 7.4 was written by me in the last element. But while printing, it has printed it first, then it has printed 9.6, then minus 1.3 is printed last. Why this has happened? I hope you understood what I am talking about. Because there is no ordering. Set is an unordered collection. So next time, somebody gives you a set, okay, shows you a set and says, I'm printing y. Tell me what will be the output. You tell all values will be printed, but in which sequence, we don't know. Correct? Maybe next time I again print y. Let's say, same set I am printing. There is no guarantee that the same sequence will be printed. Maybe some other sequence will be printed. Right now, it has printed the same sequence. It can happen, okay? First point, I hope you understood. It is unordered collection. Let's try one more thing. Print y0. What I am feeling, this is my set y, correct? Here, look, this is the set. And what I feel is this is the 0th element, just as in the list or in the tuple also. Tuple is also ordered. This is 0, this is first element. So I am trying to print only the 0th element of Y. That means I am using indexing with the set. Look, it will give error. Last line you observe in the error, type error. Set object is not subscriptable. Instead of index, we use the word index in our daily life, index or location, but technically correct word is subscript. That 0 index is known as 0 subscript. 1 index is known as 1 subscript. What it is saying is set object is not subscriptable. You can't access individual elements of the set like that. Okay, that proves that set is unordered. There is no indexing. Correct. So can you go to a particular element of the set like that? Single element of the set? No. Can you print the entire set? Yes, you can. But you can't access a particular element because you don't have index. You don't know where is that element. It can be anywhere. Correct. Inside the set, that element can be anywhere. There is no index. Okay. So I hope you have understood first two points very well. It is unordered and duplicates are not allowed. Even if you try to store duplicates, it will suppress it. Now let's come to the third point, mutable. Is set mutable or immutable? Immutable means you cannot change. You cannot change anything in the set. Mutable means you can change something in the set. Now this is confusing many times for beginners. They will immediately say, any beginner would say that set is immutable. I repeat, any beginner would say that set is immutable. Why? Simple. Anybody would feel, we know that even if we have a set, we can't go to that particular element of the set. If we can't go to any element of the set, how can we change? Because to change an element, we will have to write something like y0. Please change to some other value equal to, I will have to write y0. You become equal to 100.95. Something like that I will have to write. What I mean is that if you cannot go to a particular element and erase it and write some new value, look, it will give error. Set object does not support item assignment because there is no indexing only. How can you go there? Then any beginner, will start feeling that set is immutable. I hope you understood my point, but set is mutable. I repeat this again. Set is mutable. Set is mutable. Remember. Why? Because although you cannot change a particular value, like you can't go to a particular element and change it, but you can add new values in the set. Yes. Suppose a set is there containing 5 values. You can add a new value in the set, or you can remove a value from the set. These two operations are given. I repeat, if a set is there, you cannot change existing value. You can't go to a value and change it. But you can add new values or you can remove existing values from the set. These two operations are given in set. So you tell me, if a set is there, you can change the set. You can increase the number of elements, you can decrease the number of elements. Set can change. That's why it is mutable. Okay, I'll close this. This has become crowded. So I'll close this Python idle as my habit goes. I want fresh Python idle screen to explain this. Okay, I'll just maximize the screen. Let's make a set. X is equal to curly brace 1, 2, 3, 4, 5, 6. 6 elements. Let's try to print X. 1, 2, 3, 4, 5, 6. But don't be sure about the order. Huh? It has obediently printed 1, 2, 3, 4, 5, 6. But maybe it may print 6 first and then 1 last. You really don't know. But all the elements will be printed because ordering is not there. Okay. Just imagine I want to add, one more value 7 in this set. Currently, it is storing 1, 2, 3, 4, 5, 6. I want to add 7. Then there is a function called add given, not append. Append is in the list class. And what append does? Append will always add the new value at the end of the list. Append function is not there in the set class. Add function is there. I want to add which value? 7. And you know this will not work because we have to mention the name of the set in which I want to add. So on the left hand side of add, I will have to write x dot add. This is very clear. I want to add value 7 in the list x. Okay. So I'll just hit enter. Command is over. Let's try to print x. See, 7 is added. But again, I repeat, not necessary that 7 is added at the end. This sequence may change because there is no ordering. Okay, let's add one more value. X dot add, maybe 25. I'm adding just a value 25. And let's try to print x. Okay, here also 25 is added at the end. But please don't come to conclusion that value is always added at the end. There is no end, there is no begin in the set. It is random collection, unordered collection. Okay. Let's add one more value. X dot add, let's say 9 and print x. See how 9 is added here. It was not added at the end. It was added in the set. So ordering is not there. Okay. Okay, let's try to add 2. But 2 is already there. Then you are requesting, please add 2. But set doesn't allow duplicates. Duplicates are not allowed. So this command won't give any error. But it will suppress that second time 2 that you are storing. So if you print x, see, 2 is stored only once. So is set mutable? Yes. How? Can you change some value in the set? No, you can't change a value. But you can add new values in the set. Now imagine you don't want this 5 in the set. Then guess what? There is a function called remove. Remove 5. Which value you want to remove? But obviously left hand side will be x dot remove 5. So 5 will be removed from the set. Suppose I print x. You note 5 is not there in the set. Okay. So let's come back to our blackboard. Why is set mutable? Reason is we cannot change existing values. We cannot change existing values. I'll just scroll up. We cannot change existing values, but we can add new values and remove values. So 2 simple methods we have seen in set. Okay, just check these 4 properties. 4th property is still pending, iterable. But as soon as I say iterable, what does it strike? This word is so magical now. Iterable means you can use set in the for loop. Like you can use list in the for loop, you can use tuple in the for loop, you can use set also in the for loop. We will see that, we'll discover iterable. But first 3 properties, I hope you have understood. Okay. Right. Now, imagine we have a problem like this. I'm changing the page now. We have a problem like this. Create a set containing all values from 1 to 20. Now, one way of doing this is you can write x is equal to curly brace, because set is always written in curly brace, 1, 2, 3, 4. Like this, you can keep writing, isn't it? Keep writing up to 20. This is one way. But instead of writing so many values like this, You can write x is equal to range. We have this function, isn't it? Suppose I write range 1 comma 21. You know that automatic increment is 1 if you don't give increment in range. 1 comma 21 is going to give us range of numbers from 1 to 20. But we want these range of numbers to be stored as a set. So we use a function called set. Put it as a function. This will create x as a set, first of all, containing all numbers from 1 to 20. So what is set function? Simple. Set function creates a new set. Creates a new set using whatever values you have set. Okay. Same thing we saw, that list is also a function and tuple is also a function. We saw that. I mean, suppose you are asked to create a list containing all numbers from 1 to 20. So you can write y is equal to, I want range of numbers from 1 comma 21. This will give 1 to 20 numbers. But you give this to a list function. So what will be y? Y will be a new list, square bracketed list containing 1 to 20. Or suppose if you write z is equal to, I want a range of numbers from 1 to 21. That means 1 to 20. But make it a tuple. So tuple is a function. List is a function. List bracket. Tuple is a function. Set is a function. Okay. So this problem I was solving. How do you create a set containing all values from 1 to 20? One way is you can write all these values. Other way is that you can create a set. I will go back to idle. Just a demonstration. Suppose I write x is equal to set bracket range bracket 1 comma 21 bracket close. Then you see x is going to contain all numbers from 1 to 20. Right? Please don't come to any conclusion that it is printing in increasing order or something like that. No, there is no ordering. There is no ordering. Okay. It is just a coincidence that it is printing the output very obediently like that. But you can't guarantee that every time you will get the same output. Okay. Here we are getting it. Anyway. Huh? Okay. Let's try creating a set y is equal to set. Let's say range 1 comma 101. So this is a set containing all numbers from 1 to 100. I will print y. Okay, I hope this demonstration is not needed, but this time also it is printing everything nicely, one after the other, but it may print it in out of order also. Okay. And I think we proved it in one of the demonstrations that it is printing the output not in the defined order. Okay. But this is how you create a set on the fly. Okay. Now, what will this mean? Z is equal to set bracket. Just observe the last line. Set empty bracket. Z will be empty set, isn't it? Print Z. See, it is an empty set. It prints set bracket. That means you have a set. Z is definitely a set, but it does not contain any values. Let's try to print type. Print type Z. What is Z? We are asking. Z is a set, surely, but it is an empty set. This is how you create an empty set. Okay. I'll help you recall a few things. Just check. How do you create empty list? Two ways are there. You can write empty square bracket, or you can write x is equal to list bracket. This is clearly an empty list. This is also an empty list. Okay, how do you create empty tuple? You can write x is equal to bracket open, bracket close. Or You can write x is equal to tuple like this. This is a function, but you are not given any values to tuple function. So x will be empty tuple. Now, how do you create empty set? X is equal to curly brace open, curly brace close. Wrong. This is wrong. You can't create an empty set like this, but you should create empty set like this. Set bracket, no values. Reason will be clear when we learn dictionary. You know what? In Python, dictionaries are also given in curly braces and set is also given in curly braces. Both set and dictionary are given in curly brace. Then whenever you give this curly brace, empty curly brace, it will not be empty set, it will be dictionary. I'll prove it. Look at the bottommost line. Suppose I write Q is equal to curly brace open, curly brace close. Now anybody would feel that empty curly braces means empty set. Q must be empty set. Correct? Let us try printing type Q. What is the data type of Q? It prints dictionary. Isn't that proving that when I write empty curly brace, it will not create empty set. It will create empty dictionary. So only way to create empty set is to use this function set. Okay? Yeah. So this was the problem. Create set containing all numbers from 1 to 20. Fine. Now, just imagine this code. I'm discussing set is iterable. This is the point, fourth point I am trying to prove. Now we have a problem like this. Suppose we have a set x is equal to 1, 2, 4, 9, 3, 7, 0, 16. Some set I have created. And the question asked is, print only those values of the set which are greater than 7. So only 9 should be printed and 16 should be printed. Values greater than 7 only should be printed. The problem is that if I print x, then the entire set gets printed. This will print entire set. No, but I don't want to print all the values. My requirement is that I want to iterate. That's the word. I want to travel the values of the set and knock everyone and ask, are you greater than 7? If you are greater than 7, only then you will be printed. I hope you understood. Iterable again. So what's the way out? We can write such a for loop, you see. For some variable, let's say t, in x. I'm sure you're used to this grammar now. We have used it several times. For t in x, what is x? This is a set. We have defined it before. What is t? It's just a variable, simple variable. Here, inside this for, we will put if t is greater than 7, colon, only then print t. Watch the indentation. You are understanding that t will be each and every value one by one. Because we are saying t, you become each value in x, one by one. So t will be 1. Then is 1 greater than 7? False. So 1 won't be printed. Then loop will repeat. Then t will become 2. Is 2 greater than 7? False. So 2 won't be printed. Loop will repeat. See, again I repeat. It's not necessary that which element will be taken next by the for loop. After 2, it might take 0. Because there is no ordering. But every value will be taken by the for loop. We don't know the order in which it will take the values. The point is that set is iterable. You can directly write a for loop using a set and go to every value. But in which order, we don't know. So what will be the output? Output of this code. Only two values are greater than 7, 9 and 16. So it will print 9, 16. Or maybe it will print 16 and then 9, because it may take 16 first and then inspect it. Is 16 greater than 7? Then it will take 9, although 9 is written first. This ordering we can't say, but both values will get printed, definitely. Okay, let's check. What I will do, I'll type a new file now. Let's type a program. Okay, I'll just close this again. Open new idle. So I'll type a new file. Let's make a set. I'll just maximize this. X is equal to 1, 3, 14, 4, 6, 8, 7, 99, 0, 12. And we want to print only those values, which are greater than 7. Then I will write for some variable. Again, remember, variable name can be anything. P, Q, R, S, whatever. It should be other than X, because X is our set. For T in X, colon, let's ask what is T. If T is greater than 7, colon, print T. That's it. I'll save this with my favorite name, trial. It's already exists. I'll overwrite it. Let's run this. See, it has printed 99 because 99 is greater than 7. But 99 was here actually. Before this, even 14 was greater than 7. What I am telling is set is unordered. Correct? So we really don't know what value will be fetched by T. It's not necessary first time it will fetch 1, next time it will fetch 3 and so on. Correct? So 99 obviously is greater than 7, then 8 is greater than 7. So it took this value. Then 12 is greater than 7. Yes, 12, this value. And then it took 14. Of course, it took all these values also. It inspected. Is 1 greater than 7? Is 3 greater than 7? But in which order? We don't know. Our point is, set is iterable. You can use set like this in the for loop. Okay. Just check this code. I'll wait for some time. Okay. So, because we are heading towards a program now on set, it's again about filtering the set in 2 categories. And I want to tell you about set comprehension. We have learned list comprehension. I hope you are in touch with that. Or maybe if you lost it, I mean, last time you didn't learn comprehension, today is the chance you can learn comprehension with me. So let's try to write a code now. Let's say we are given a set like this, given set X with some values. Let's say 10, 5, 19, 2, 7, 16, 15, 0, 99, and let's say 4. And we want to create 2 new sets. Create new sets. First set is A, which stores values greater than, let's say, greater than, let's say, 18. And B stores values less than or equal to 18. That means set A should store 19. 19 is greater than 18 and 99. That's all. And B should store 10, 5, 2, 7, 16, 15, 0, 4. But we are not sure about the order again. But these values must be there in both the sets. Okay. I'm sure you have started constructing the code because we have seen such type of examples, 8 or 9 programs we wrote using list and comprehension also. Let's begin coding, okay? First, I will make this set in my Python program. X is equal to, this is my set, 10, 5, 19, 2, 7, 16, 15, 0, 99, 4. Or you can take any set. After all, we are just trying the code. Now, what do you say about this? A is equal to set, bracket. B is equal to set, bracket. We have made two new sets. And these sets are empty sets. Remember, empty set cannot be made by using curly braces. Curly braces, if you write empty curly braces, it will not create a set. It will create an empty dictionary. We want a set. Okay. Now, these two new sets are there. Now, what I want to do is I want to go to each element and check, is it greater than 18? If that value is greater than 18, then we will add. Add is the function, remember. You can add new values in the set. We will add that value which is greater than 18 in set A. Otherwise, we will store it in set B because it is surely less than or equal to 18. That means we need to iterate. We want to go to each element and choose them according to their value. So we will write for t in x. Are you following? This t is a simple variable which will take each and every value one by one. And then we will put if that value t is greater than 18, colon, then if it is greater than 18, what do you want to do? Add that value t in set A dot add. I hope you understood. And obviously, you might have jumped to the conclusion that else, which is correct, else colon will write b dot add t. Because then t is less than or equal to 18, surely opposite of greater than. So we want to add it in b. We will keep repeating this loop for all the values of set. And finally, we will outdent. That's very important. We'll come out of the loop and then we'll print A and finally we'll print B. Print B. Just check this. This program demonstrates that set is iterable. And how do you use that add function? Initially, you can make an empty set. Then you can keep adding the values in the set of your interest. Here, the interest is if it is greater than 18, add it in A. Otherwise, add that value in B. Okay. So I'll go to idle. Here, same program we will update. I'm not creating a new file again. Okay. And let's say we want here, we want all values greater than 8 in set A. Instead of 18, I am changing the problem. Greater than 8 in A, less than or equal to 8 in B. So create an empty set A, create an empty set B, and then for some variable in X, if that T is greater than 8, that element is greater than 8, then A dot add T. Remember, we have to now hit backspace key, and then write else. Again, I am indented because I have written colon b dot add t, because this value is less than or equal to 8. And now I have to hit backspace, again backspace, so that I come below the for loop. I am now outside the for loop, and I am saying print A, print B. That means A and B will be printed only finally when the for loop ends. Okay. I'll save this and run this. Just check. Set A has all values greater than 8. And set B has all values less than or equal to 8. Just check the code. Okay. Okay. Now I have a difficult question to be asked to all my dear boys and girls. Because we have seen list comprehension in big detail, we have seen. My question to all of you is that you can create the set A just in one line using set comprehension. Write a set comprehension. And you can create set B using set comprehension just by using one line. Okay. I will give you grammar of set comprehension. It will not be different from list comprehension. The syntax. By the way, this is my question. How will you create set A? Remember, set A needs value greater than 18 in this example. So we must get all values greater than 18 from set X in set A and less than or equal to 18 in set B. You can continue thinking of this. Meanwhile, I am writing the syntax of set comprehension. You will take some time, I think, to type this in the chat. Okay, but the syntax is curly bracket expression, then for some variable in the set name. Here set name is X. Then if condition, curly brace close. Just check this. Same grammar we had in list comprehension also. Only thing is we had square bracket instead of curly bracket. Okay. How will you tell Python that in set A, I want all values of X which are greater than 18? Just check this. What will be the statement you will write for A? A is equal to curly brace what exactly? Okay. See, what should A store? After all, values from X. So we'll write for T in X. What will the for loop do? Recall the list comprehension. This for loop says T should become each and every value of X one by one. But in which order we don't know. But T, there is an answer. I was sure actually. And I'm sure more answers would be there, but people are taking it a bit longer to type it. Okay. Very good, Pranay. For T in X, that's what we have written here also, you see, for T in X. And then we will put if that value T is greater than 18, only then add a T in A. What I want to say is, instead of writing such a big code like this, same thing can be done in one line. What is comprehension? On the right hand side, this what we have written, you know, this line is called set comprehension. Why is set comprehension used? So that instead of writing so many lines that we have written on the left hand side, a bigger code, you can crunch it in one line. No other use of set comprehension is there. Suppose you hate this. Imagine you hate this. No problem. You write that left hand side code because that is also working anyway. But if you know set comprehension, you can write it in lesser lines. That's the only advantage of this. And notice, when we have written the set comprehension, you know, we have written everything that we have written on the left hand side. On the left hand side, we have written for T in X. Here also we have written for T in X. Then when we enter the for, we are checking is T greater than 18. Here also we are checking if T is greater than 18. And if this condition is true, only then that value will be added in A. So which values will be added in A? Only those values which are greater than 18. So when this for loop starts, you see, okay, I'll write it on fresh page. Here it is. Suppose X is 10, 15, 28, 0, 18, 9, 19, 99. This is set X. And I have written the statement. I'm so sorry. I have written the statement A is equal to set. This means I am creating a set. Curly brace I have given. So look inside, I am writing for T in X. So T will be 10. Then next T will be 15. Next T might be 18 because we don't know in which order it takes. But all values will be taken one by one. And then we check if T is greater than 18. If this is true, we are saying only then add that T in A. So obviously set A will contain all values greater than 18. And similarly, we can write B is equal to one more set we want. We'll write for T in X. Take all values from set X. If T is less than or equal to 18, if this is true, then add that T in set B. So no need of writing such a big code, line after line. You can write it in one line like that. This is called set comprehension. Now, how do you know it is set comprehension? Due to these curly braces. Suppose I write C is equal to square bracket T for T in X. If X is greater than 18, then, oh, I'm so sorry. Suppose I write square bracket. Entire thing I have written in square bracket, then C will be a list. List of all values from set X. X is a set. But only those values which are greater than 18. So C will be a list of values from set X. Why list? Because we have written that comprehension in square bracket. It is so simple. Grammar is same. Only thing is, it depends on what you are writing, square bracket or curly bracket. Okay. Okay. This writing this T itself means T is added in A. Okay, he says. Okay. But nice work done. Okay. Now, I'll go back to our code, and it seems that we were wasting our time by writing so much of code, right? We don't even have to create the empty sets. I'll write just A is equal to, I want a set. Now, values are going to come from X. So, T in X. If T is greater than 18, only then add that T. That value which is greater than 18 should be added in A. And I'll just copy paste this. B is again a set made from values of set X. So for T in X. But if T is less than or equal to 18, only then add that T in set B. And finally, I'll print A and B. So if I run this, okay, it says source must be saved. Okay, I did not save the file. I'll say, okay, save it. There is invalid syntax. Something went wrong here. I don't know why I typed letter S there by mistake. I've typed letter S. Okay. I'll save this again and run it. Yes. You can see that set X contains all values which are greater than 18. And only 99 is greater than 18. Other values you see are less than or equal to 18. So all other values were sent to set B. Yeah, B is storing all values which are less than or equal to 18. This output is not matching because we checked greater than and less than or equal to 8 last time. If I check it for 8, the output will match. No need of doing this, I'm sure. Yeah, you can see. This output was for greater than 8 and this output was for less than or equal to 8. Great. Huh? This is set comprehension. Okay, I have a question for all of you. I'm sure. Please, everyone participate in this. Okay, I have a question. I am giving you a code. Let's say X is equal to, let's say -2, -1, 0, 1, 2. You know, set can contain any values, negative, positive, but repetitions are not allowed. Okay. Now I will write A is equal to uh, curly brace for T in X, curly brace close, T raised to 2. My question is, what are the values in set A after this comprehension is done? You understood this for loop. This T in X means T will become -2, -1, 0, 1, 2, each value it will take. And we are storing T square of that value in A. So in the chat box, you should tell it as a, or don't type curly brace. It is very boring. We understand that you are printing A. So just give me the values. What values will be there in set A? Separated by comma. I hope you understood the question. Which values will be there in set A? I have got the answer. Uh, Somebody answered -4, -2, 0, 1, 4. Just check your answer. Huh? Okay. Lahati, is it? Just check your answer. You are saying 0, 2, 4. Okay, I can see some new students answering. Very good. Okay. By the way, the answer is A will be 0, 1, 4. Only 3 values will be there, isn't it? Yeah. Or 4, 1, 0. Anyway, sequence is not necessary. You see, what is this for going to do? It's going to take T as -2. Okay, let's say T is -2. Then T square, that is -2 square. -2 into -2 is 4. So A will then contain 4. Correct? Next time when the for will repeat, it will take -1. Again, I don't know the order. We are assuming -1 is taken next. So if T is -1, what is this? T square. That is -1 square. That is A will now store 1. Then T will become 0. In this for loop, T will take next value. T is now 0. And 0 square is added. That means 0 is added. Then next time T will become 1. It will take each and every value of the set. Notice when T will become 1, what will be added? 1 square. 1 square is 1, but 1 is already there. I hope you have understood. And same thing will happen for 2. 2 square is 4. 4 is already there. It won't be added again. So the answer is 0, 1, 4 or 4, 1, 0 or 1, 0, 4. Sequence is not important. Right? Okay, well said. Yeah, now yeah, correct. 410. Okay. I'll just open up a new page. Let's open up a topic. Methods or functions of set. Remember what were the methods of list, append, extend, remove, insert? So many functions were there. Which are the methods of set? Oh, we have already learned a method called add. We have learned remove. We took a demonstration also for this. For instance, suppose X is 1, 2, 3. Simple set I am taking. And if I say X dot add 4, then new value 4 is added in set X. Or suppose if I write X dot remove 2, then 2 is removed from the set. Removed from set. Okay. Now, you know, there are 3 very important methods in set class, which we will be using heavily later on. Union of two sets, then intersection, Okay, union, intersection, and difference of two sets. That I will demonstrate in next 15 minutes. Okay, I'll scroll down. Let's take a demonstration. Third method I am writing. Two methods, add, remove, are there. Union. There is a method called union. Imagine I have x is equal to 1, 2, 3, 4, 5. And I have another set y is equal to, let's say, 3, 4, 5, 6, 7. And I say z should become x dot union y. Take your own time to understand that line. We want to find union of two sets. We want to find union of x and I'm not explaining union. Huh? That will be insult of your intelligence, isn't it? Or your knowledge. Huh. How to write it in Python, I am telling. I want to find union of x and y, two sets. Then any method of set has to be called using dot, like x dot add, x dot remove. So I have called union on set x, but I am saying unite this x with y. So y I have written in the bracket. So what will be z over here? Z will be union of two sets. It will be a new set. Here z will be a set, isn't it? Has to be. Union of two sets is a set. And z will store 1, 2, 3, 4, 5, 6, 7. Union of both will be taken. So 3, 4, 5 is repeated. It will be stored only once. Z equal to x dot union y. You understand that union is commutative. That means if I write P is equal to y dot union x, won't make any difference. I'll get same values. So sorry, P will be same. 1, 2, 3, 4, 5. Again, ordering we don't know, but these values will be there. Values of both the sets. Collectively, both the sets. So simple, union operation. Okay. Now there is one operator given. Just see. We can write like this also. This is interesting. X pipe y. Like this you can write. You don't have to write x dot union y. You can write if you want. But instead of typing x dot union y, you can use that operator, vertical bar, pipe. It is given, that pipe is given just above enter key. Just above enter key, there is backslash key. Just above that, there is pipe, vertical bar. This actually means, this means Q is x dot union y. Same as what we have written above. It's a shortcut operator. Okay. Let's go to idle. I'll just close this idle. Open a new one. Okay. Just check. Suppose I am having x is equal to 1, 2, 3, 4, 5 and y is equal to 3, 4, 5, 6, 7. Okay. And if I say z equal to x dot union y and print z. So z will be union of both the sets as you see. But I can also say P is equal to x, then pipe y. This pipe here means union of two sets. If I write print P, P will be a new set. It is also union of both the sets. What is pipe? It is an operator, like plus is an operator, minus is an operator. That pipe is an operator which is used on sets to find union of two sets. Just check this. So I am not going to Blackboard now. See, we will continue here only. We have seen how to find union. You can either use union function or you can use operator, pipe. Then there is one function called intersection. Okay. It's not intersect, it is intersection. So suppose I say Z is equal to X dot intersection Y. So I am finding intersection of X and Y. But this dot is important. We should call the function on one of the sets. So I have called intersection on X and I have passed Y. Okay. So Z will be a new set. Suppose I print Z. It will be 3, 4, 5, obviously, because intersection is common values between the two sets. Correct. But we can find intersection like this also. You say P is equal to X, single AND. That AND is given above that 7, key 7, number keys 1, 2, 3, 4. Above that 7 AND keys, ampersand key is there, and Y. This is a shortcut for intersection. So, same result we will get for P also. 3, 4, 5. I'll go to the board. So, first function add, you got that. First function was add, second was remove, third is union. Fourth we saw was intersection. I'm not writing it. I hope you copied that content or you got that. Remember, AND is a shortcut for intersection. Now, the fifth is difference. Okay. We need some discussion over here. Difference of two sets. So I'll open a new page. Okay. Let's see difference, fifth function, difference operation. Let's take an example. Suppose X is 1, 2, 3, 4, 5 and Y is 3, 4, 5, 6, 7. And suppose I write Z is equal to X dot difference. Difference is the function, bracket Y. Then we will write that description very carefully. Z is a set. Definitely. Z is a set that contains all values that are present in X. That are present. This is present in X and not present in Y. Not present in Y. Just first of all, you take down this very carefully. What will that new set Z contain? Those values which are there in X but not there in Y. So common values won't be there. One way of looking at it, you may think about that. Carefully find difference. My appeal to all of you is whenever you find difference, you carefully find it. How do you find it? You see, I'll write for our reference, we'll write again set X is 1, 2, 3, 4, 5. Y is 3, 4, 5, 6, 7. Okay, now what difference are you finding? You are finding X difference Y. You are not finding Y difference X. I repeat, you are finding X difference Y. You are not finding Y difference X. I repeat, you are finding X difference Y, not Y difference X. Okay, keep this in mind. So, suppose I write Z is equal to X dot difference Y. Now, Z will have all values that are present in X but absent in Y. So what you do is you look at set X only. First, you look at set X only. Don't look at set Y. Okay, look at set X. Take this one. It is present in X, obviously. It is present in X. And it should be not present in Y. Yes, 1 is not present in Y. 1 is such a value which is present in X, but not present in Y. Then this Z will contain 1. Okay, next value 2. Look at X only. 2. 2 is present in X and 2 is not present in Y. 2 is not there in Y, you watch. So 2 will be there in Z. Okay, next value, 3. 3 is present in X and 3 is present in Y also. Then 3 will not be there in our result. Okay, next. Please keep listening properly. Okay, 4. 4 is present in X and 4 is present in Y also. Then 4 will not be there in our result. 5. 5 is there in X and it is there in Y also. Then 5 also won't be there in X. Finished. Z will be 1, 2 only. Now many students get confused here. Why 6 and 7 is not there in our result? I repeat, many students are confused that why 6 and 7 is not there in our result. Please try to understand. We are finding X difference Y. Those values which are there in X but not there in Y. So only 1 and 2 are the values which are there in X but not in Y. That's it. Matter ends. So here Z is going to be 1, 2. Patience. Look at this. What if I write P is equal to Y dot difference X? Be sure you understand this. Now we are finding Y difference X. How do you read this? Y difference X means those values which are there in Y but not there in X. So now you have to see the set Y first. Value should be there in set Y and then search it in X. If the value is there in Y and not in X, only then it will be there in our result. I hope you got this. So what will be the result? Let's see. Yeah, you've given the result already. I can sense that. Okay. Y difference X. See, 3 is there. So here P we are finding. This result. 3 is there in Y, but 3 is there in X also. So 3 won't be there. 4 is there in Y. Look, I'm looking at Y set, right? 4 is there in Y, but there in X also. So 4 also won't be there. 5 also won't be there because it is there in Y and X. 6 is there in Y, but not in X. 7 is there in Y, but not in X. That's it. That means here P will be 6, 7. Do you understand? Difference operation is not commutative. Union is commutative. X union Y is same as Y union X. Intersection is commutative. X intersection Y is same as Y intersection X. But X difference Y is not same as Y difference X. Values will differ. Okay. And guess what will be the shortcut operator? Minus. Obviously, you can write this statement like this also. P is equal to Y minus X. Oh, great. This minus symbol is now not subtraction. This minus symbol means difference. And you know what difference means. We have defined it. Correct? Like this also you can write. Y minus X. Now it will not subtract anything. It will then find all values which are present in Y but not present in X. Meaning is different here. This is not that ordinary minus. Ordinary minus subtracts. Like 3 minus 2, it will give 1. This is not subtraction. Okay? Okay. So I'll just go to Python idle. We have these sets, isn't it? X is still 1, 2, 3, 4, 5. Y is 3, 4, 5, 6, 7. Let's try to say Z is equal to X dot difference Y and print Z. Oh, look at that. 1, 2. Okay. And what if I say P is equal to Y dot difference X and print P? It will print 6, 7. And I can write the same thing as P is equal to Y minus X. Oh, P equal to I missed out. Sorry, this line, equal to I missed out. I'll just correct my mistake. P is equal to Y minus X. Great. And if I print P, it's going to print the difference 6, 7. That's the difference between Y and X. Okay. Just check this page. The difference operator, difference method. Actually, our plan was to learn dictionary also, but it always happens, You might have now understood nature of your teacher. He always writes more topics. On next class, we will learn dictionary. But remember, our goal is finally when we learn dictionary also, we have to put all these collections together. That means we'll go back to list, then again tuple, collect them. Is there any relation between list and dictionary? Is there any relation between set and dictionary? Or in which kind of programs will you use list? You won't use dictionary. In which kind of programs you will use dictionaries? I don't know whether you are solving some, programming assignments which are asked on online platforms like Leet Code. There is one famous, very famous uh, online platform called Leet Code, and many more are there like this. Uh, Maybe many of you might have tried. And Leet Code, is a big ocean which contains so many programming assignments that you can solve online, of course. You can type the program and submit. Then Leet Code will tell whether the program is correct or not. It has test cases. I'll tell you, maximum problems in the Leet Code, can be solved by using list or dictionaries. Maximum problems. And my goal, is to show you at least 4 or 5 such questions from Leet Code. How they ask the questions, how test cases are there. Okay. But that is possible only after taking this whole circle, after learning all these, collections properly. We can think how people are judging us outside, that whether you know programming or not. Okay. Any questions till now? Okay. A short uh, mention about there is one word, polymorphism. I hope you have heard this word, polymorphism. Very famous word in programming, especially in object-oriented programming, OOPM. And in all technical interviews, wherever you go, favorite question asked by interviewer is, do you know what is polymorphism? And then, people unnecessarily, I have observed, why people give such big definitions while answering. Candidates give big definitions. Polymorphism is a process in which an entity may have multiple appearances. Poly means many, morphism means appearance. Good answer. Poly means many and morphism means appearance. Somebody's mic is on. Please switch off the mic. Whenever anything has many appearances, we say it is polymorphism. Okay. This is bookish definition. You see, technical interviewers, are not interested in listening to big definitions and all that. You say polymorphism, of course, you say many appearances means polymorphism. And next question they will ask you is, do you know any example of polymorphism? Then what people do, they write big OOPM program and then say, look, in this is polymorphism and so on. Why you are writing big program? You tell the interviewer, you want to see polymorphism in Python. Here it is. I'll open a new page. Polymorphism in Python, you want. Okay. Suppose I write z is equal to 3 minus 2. Then this minus has meaning subtract. But if I have, let's say, x is equal to 1, 2, 3, 4, 5, x is a set, y is equal to 3, 4, 5, 6, 7. And if I say z is equal to x minus y, now this is a set and this is a set, then this minus is not subtract, but it is difference of sets, where meaning is different. So you tell the interviewer, don't you see that the same symbol minus minus have multiple appearance? This is polymorphism. So Python internally uses polymorphism so that Python has given us the comfort. Programmers are comfortable. If Python said, no, minus is already used for subtract, you want a shortcut operator, then use something like this, minus minus y. This could have been absurd, isn't it? It would say, no, minus is already for subtract. What it did, it gave multiple meaning to the same operator. That's polymorphism. Believe me, if you look at the language from this perspective, then people will be very happy listening to you. Okay, and many other places polymorphism can be seen in Python. So you don't have to give big code to explain polymorphism. Okay.